Hello, in this video we're going to talk about graphs and their representations. Graphs is a non-empty set of nodes, or sometimes we call them vertices, and a set of arcs or edges such that arcs connect two nodes. For example, here we have San Francisco and Chicago. They are two vertices or nodes and they are connected by an arc. And in our examples, we're going to see only finite number of nodes and arcs, not infinite number of nodes and arcs. So here is an example here where we have cities and then some arcs connecting the cities. So this is an informal definition of a graph, and it works quite well if we have the visual representation of the graph before us to show which arcs connect which nodes. However, without this picture, we need a concise way to convey this information, and therefore we're going to need a formal definition of a graph. So a graph is an order triple. So you have N, the nodes, A, the arcs, and G, the function. N, non-empty set of nodes, A, a set of arcs, G, a function associating with each arc A, and an order pair xy of nodes called the endpoint. Here is an example here. It says sketch a graph having nodes. So you have 1, 2, 3, 4, 5, and you have these arcs A1 to A6, and function G1 represented from 1 to 2, G of A2 represented from 1 to 3, and so on. So take a minute and try to draw this graph based on this definition. So right here I draw the vertices. I have 1, 2, 3, 4, 5. And so A1 is connecting 1 to 2. A2 is 1 to 3. A3 is 3 to 4. And another A4, which is 3 to 4, so we call them parallel arcs. A5 is 4 to 5, and A6 is 5 to 5. That means you have a loop. So this is how we draw a graph based on this information. Directed graph, which means the arcs of the graph begin at one node and end at another. For example, this one is directed graph when you have some arrows. So the definition for directed graph is similar to non-directed graph and directed graph. You need a set of nodes, set of arcs, and a function g, but you have, instead of 1 dash 2 or x dash y, you have an ordered pair. That means you start at x and you end at y. So x called the initial point and y called the terminal point, because you have a vector. Directed graph therefore has a direction associated with each arc. Let's see this example. How many nodes and arcs in the example below? State the function g associated arcs with endpoint. So we could take a minute and try to find how many nodes, how many edges, and the function. So as we can see, we have 4 nodes, 1, 2, 3, 4, and we have 5 arcs, A1, A2, A3, A4, A5. A1 is the function for A1, G of A1. It takes start at 1 and end at 2. Therefore we have the order pair 1, 2. The same way for A2, we start at 1 and end at 4. For A3, we start at 1 and end at 3. For A4, we start at 3 and end at 1. And for A5, we start at 4 and end at 4, because it's a loop. Let's look at another example here. Give the function g that is part of the formal definition of the directed graph shown. So here is another directed graph. We just need to find out where is the function for this graph. So take a minute and try it. So as we can see is that G of A, it goes start at 1 and at 2, G of B 1, 2, 3, G of C is 2, 2, 3, and G of D is 2, 2, 2. Now let's learn some terminology that deals with graphs. So we have labeled graphs, a graph whose nodes carry identifying information such as names of the cities in the map of airline route. Weighted graphs, a graph where each arc has some numerical values or weight associated with it. Here is an example. So this is labeled as also has some weight. That means maybe to fly from Seattle to LA, $70, Seattle to Dallas, $120, and so on. So this is a labeled and weighted graph. Labeled and weighted graph, this one. And so when you have two nodes in the graph are adjacent, like 1 and 3, they are adjacent, if they are the endpoints associated with an arc. So 1 and 3 adjacent, but 1 and 4 is not adjacent. Okay. What is a loop? As I mentioned earlier, this is a loop. A3 is a loop. So we have a loop here. And what is a parallel arc? So A1 and A2 are parallel arc. And this is very important. You may see it in questions. Simple graph. A simple graph is a graph with no loop, no parallel arc. So this one here is not a simple graph. So if I take 1, 2, 3 by itself, then this is a simple graph. An isolated node is adjacent to no other nodes. For example, A5 here is an isolated node by itself, not connected with any other node. And now the degree of nodes. What is the degree of nodes? So node 1, for example, if you look at it, it has 1, 2, 3 degrees. Node 3 has 1, 2, 3 degrees. Node 4 has 1 degree. Node 2 has 1, 2, 3, 4, 5 degrees. So this is how you see how many degrees in each node. So how many arrows coming out from that vertex here. A path is like a sequence of node arcs, like how you go from 1 to 4. I could take this path 1 to 2, 2 to 3, 3 to 4, and so on. That's what a path is. Here is an example of path. A length of a path is the number of arcs. So if I choose this path, as I mentioned earlier, 1 to 2, 2 to 3, and 3 to 4, so the length is 3. I mean, how many arcs we have in this path. The length of path is the number of arcs it contains. If an arc is used more than once, it is counted each time it is used. The length of the path described above from node 2 to node 4 is 4. So based on this one is given, you have 2, 1, 2, 3, 4. A graph is connected if there is a path from any node to any other node. So this one here is not connected graph because 5 is not, we can reach it. So what is a cycle? A cycle in a graph is a path from some nodes n0 to back to n0. So I could go 1, I go 2, 3, and back to 1. So here is a cycle where no arcs appears more than once in the path sequence. And 0 is only node appears more than once. When you start at n0, you come back to n0. So that's what the cycle. And a graph with no cycle, we call it a cyclic graph. It has no cycle. Let's see this example. So read the question, and I would like you to stop the video and try it yourself. So what we have here, it's asking us to sketch the picture of each of the following graphs. So A, we want simple graph. So review, what is a simple graph? With 3 nodes, each node will have 2 degrees. Think about it. For B, I will need to draw a graph with 4 nodes with a cycle of length 1, 2, 3, and 4. And for C, we want a non-complete graph with 4 nodes, each with degree 4. So stop the video and try this and let's see what you can get. So for A, here is a simple graph with 3 nodes, 1, 2, 3, and each with 2 degrees. For B, a graph with 4 nodes with the cycles of length 1, 2, 3, and 4. So we could start 1 to 1. There is 1 cycle. 1, go to 2 and back to 1. Here is 2. Cycle is 2 now. And a cycle with length 3. If I start at 1, I could go to 3, 4, and back to 1. So here we have cycle 3. And for cycle 4, I could do 1, go back to 4, 3, and then back to 1. So here is cycle 4. So right here we have I start at 1, come back at 1. So I have cycle 1, a cycle 2, cycle 3, and a cycle of 4. And non-empty graph with 4 nodes, each with degree 4. Okay, non-empty, and with graph each with degree 4, with 4 nodes. So here we have 4 nodes. So what I'm thinking about, so if I go to 2 and back to 2, I have now 1 has 2 degrees. So if I continue this way, now 1 has 2 degrees. So if I continue the same logic, I could see now I have 1 has 4 degrees, 2 has 4 degrees, then node 3 has 4 degrees, and node 4 has 4 degrees. Because the function g that relates arcs to endpoints in the formal definition of a graph is indeed a function, each arc has a unique pair of endpoints. If g is one-to-one function, then there is at most 1 arc associated with a pair of endpoints. Such a graph have no parallel arcs. So now we're talking about the subgraph. What is a subgraph? A subgraph consists of a set of nodes and a set of arcs that are subset of the original nodes. So this one is subset of this one. As you see, it's just part of it. So that this graph here is subgraph, or this big graph here, in which the endpoints of an arc must be the same node as the original graph. Below is a complete subgraph of the graph from earlier. So a complete graph is one, again more terminology here. A complete graph is one in which any 2 distinct nodes are adjacent. Kn, for example, denoted the simple. A complete graph with n nodes. So what does it mean, complete graph? If I have for k5, I need 5 nodes, for example. Let me write them down. 1, 2, 3, 4, and 5. And every node is connected with other nodes. So 1 connected with 2, with the 3, with the 4, with the 5. 2 connected with 1, with 3, with 4 and 5. 3 with 1 and 2, 4 and 5. And 4 with 1, 2, 3, 4, and 5. And 5 is connected with 1, 2, 3, 4, 5. So this is K5, because every node is connected with every other. So you could draw it a little bit different, but this is one way. For example, if I K3 will be like this. So this is 1, 2, 3. 1 is connected 1 and 2. 2 connected with 1 and 3. 3 is connected with 1 and 2. So this is again a complete graph. For K4, you could think about it as well. 1, 2, 3, 4 if you want. And so here we go. 1, 2, 4, 2, 1, 4, 3, 3, 1, 2, and 4 with all of them, and so on. So we'll stop here with terminology. In the next video, we're going to see more about graphs. I hope this is helpful.